Welcome everyone. So my name is Yunhao and I am a software engineer from Notion, and I'm super happy to be here with you all today to share my experience working with Airflow, especially how the scheduling work in Airflow. So here's the agenda for my talk today. First, I'm going to talk about what is Notion and how we use Airflow at Notion. The next, I'm going to walk through the time-based scheduling and also the event-based scheduling, the event-driven scheduling. And I'm going to talk about the different type of event-driven scheduling, which are the dataset and the assets. Then I'm going to talk about how you can choose the right type of scheduling for your DAG. And in the end, I'm also going to share some tips I learned in migrating the DAGs between different scheduling strategy. So before we get into scheduling, I want to give a bit of context on Notion and where Airflow fits into that picture. So Notion is an all-in-one workspace where people use it to write, plan, and collaborate. We serve a wide ranges of customers, from major enterprises like OpenAI, RAMP, and Astronomer, to countless individual users, including students, creators, and artists who rely on Notion to plan their day-to-day work. And as you could imagine, we have a data platform team in the back that supports the analytics, search, and machine learning features. And Airflow is a critical piece of that ecosystem, as it handles the data orchestration for pipelines, such as block data processing, during which we transform and aggregate user-generated blocks of data for analytics and product insights. We also have feature training pipelines, during which we prepare the data and the features used by recommendation and AI models. So in data pipelines, we all know that timing is everything. And in my opinion, Airflow kind of started itself as a replacement of the old cron job orchestrator. And some people even jokingly called Airflow a glorified version of cron scheduler. So in the early days, we set DAGs to run at fixed time, whether it's hourly, daily, or at a certain time in a certain duration. And we are kind of like just crossing our finger and hoping that the data will be ready when the DAG is triggered. And sometimes it was, and sometimes it wasn't. And in the example here, you can see that we have an upstream DAG running, and the downstream DAG run in with a cron scheduler. And in the downstream DAG, we have an external task sensor that's waiting for the status update from the upstream. So the dependency is established between the two DAG via the external task sensor. So diving a little bit deeper into the tools we have in addition to the cron scheduler, we often have sensors, operators, or external API triggers that are used in conjunction with the cron scheduler. So sensors will require the downstream DAG to still schedule periodically, and then we'll wait sometimes for a very long time for the upstream to complete, and then we know, okay, now we are ready to run our DAG. We also have the trigger DAG run operator, which is the push mechanism. So it's the upstream, when using this operator, it can push to the downstream and trigger the downstream to run. And we also have external trigger, which is either via REST API call or the CLI call. So these are tools we use in conjunction with the cron scheduling to fulfill our different ways of starting a DAG. And in this cron scheduling, we see a lot of the pain points. The first one is that sometimes we start the DAG when the data isn't fulfilled yet. And this will lead to either failures, empty run, or partial results. And this often requires to put a wait sensor that is additional checking. And the second pain point is the cascade backfill. So a lot of time we have a chain of DAGs that are depending on each other. So the sequence of the DAG run should be A first run, and then B and C and D. In a cron scheduling, if A failed, B, C, D will all fail. And then when we are trying to backfill the data, we need to actually manually trigger A to run, and then manually trigger B, and then C, and then D. And this is really painful, especially as the chain gets like longer and longer. And the third is that the execution date logic is pretty confusing because Airflow scheduler historically runs a job after the period ends. So for example, if we have a daily job that's scheduled for, let's say 2025, 1st of January, it actually is kickstarted the run right after the midnight at the end of 1st of January. So sometimes it's confusing to see a DAG running on today's run, but it's showing like yesterday's date. In the end, it's truly wasting resources to have so many wait task sensors that just keep pulling from the upstream and checking on the status, where our compute resources can be used in other places that are more important. So here comes the big question. Does the time-based scheduling really make sense in all cases? If we step back and apply the first principles, I think the answer is obvious. It will be actually great if our pipeline run whenever the data or the event is ready, instead of at an arbitrary time. And most of our modern data architecture is actually moving towards this direction, which is more event-driven and more real-time processing. Take our company's use case, for example, we have this data ingestion and ETL pipelines. And it will be beneficial if we can kick off this transformation job right after the raw data lands, instead of just at a certain time every day blindly. And also, we have a lot of machine learning training, so it will be helpful if we can start training a model as soon as the freshly labeled data is ready, or when features are updated, instead of waiting for a nightly schedule. So the trend is clear. We want lower latency and more real-time data flow, as businesses want insights as soon as possible. And waiting for that top of the hour or even top of the day batch might be too slow. So the Airflow community sought ways to make workflows more data aware and event reactive. In 2022, Airflow 2.4 introduced a concept called datasets, and it is a game changer for how we handle cross-stack dependency and event-based trigger inside Airflow. So what is dataset? So dataset is basically an abstract handle to some piece of data. Maybe it's a table, maybe it's a file, and a task will produce the dataset, and another DAG will consume the dataset. So in the example here, you can show that we first define the raw data, and then in the upstream DAG, we declare that this DAG is producing to this dataset through that line outlets equal to the raw data. And then in the consumer DAG, instead of saying that the schedule equal to some Cron scheduling, we declare that the schedule equal to the raw data. So whenever this data set is updated, the consumer will know automatically that it should trigger a new set of run. And this replaces the rigid cron timing. So the benefits of adopting datasets are obvious. First, we can get rid of the weight sensors because the systems now knows when DAG B depends on dataset from DAG A, so it can orchestrate automatically. And we don't need to write custom sensor code to pull DAG A status because Airflow just knows A is done because the dataset got updated. It also reduces the scheduling latency because DAG B can run immediately when DAG A finish and produce data instead of waiting for the next scheduled intervals. So this moves us closer to the event-driven behavior and improve the data freshness and data landing time. It also simplifies data DAG code because instead of each code carrying logic to trigger the next or check upstream completion, you can declare the dependency via the data directly. And it also provides better lineage information, as in the Airflow UI, you can see directly what data set is produced by who and consumed by who. However, the dataset does have its own limitation. The first one, which is the biggest, is that it can only listen to airflow events that's happening in airflow because the dataset mechanism only catch events from airflow task. So if the data is produced outside of airflow, let's say an external process upload a file in S3, airflow wouldn't know. So it's only event-driven within the airflow ecosystem, and it has no connection to the outside world. The second is that if you look at the implementation, the dataset is merely identified by the name or the URI. So the airflow doesn't really have any context on what exactly is updated in the dataset. For example, which dates are updated or which partitions are updated. And in the end, you need to be very careful when it comes to backfill again, because the dataset mechanism works that when the downstream DAG is running already, if there's a new update to the dataset, it would not be able to pick up by the downstream DAG if it's already running. So that means that when we are actually like backfilling and there are a bunch of dataset update from the upstream, the downstream might not be able to capture all the updates from the upstream perfectly. Well, the story gets better in Airflow 3. So Airflow 3 released the concept of assets. And as I see, it's a huge improvement from the dataset introduced in 2.4. So it could do a lot of the stuff that dataset was able to do. For example, it also supports like listening to the internal events, and it also supports logical operations. For example, you can listen to like data produced by A and B or A or B. So you can come up with complex condition through using different ops. But the big difference between the datasets and assets is that assets is able to listen to what's happening outside the Airflow world. So now you can subscribe to SQS queue, Kafka stream, and also S3 notification. For example, we have DAGs that are listening to S3 file upload. In the past, we have S3 key check operator that check on whether a certain key/file exists in S3. And now we can just subscribe to S3, and we will get a notification whenever a new file is updated to a certain S3 bucket. And how that is used in practice is that we declare the S3 asset, and then we create a S3 asset watcher that is watching the external resources, and is able to kind of like give an update back to this asset we created. And in the downstream DAG, you can see that the schedule is just pointing towards that asset. So now in Airflow 3, you can use, you have a variety of choices. You can still use the clock-based orchestrator, but you can also use the event orchestrator via the asset. And you can actually also use a combination of those two by using the asset or time scheduling. So the UI and internals are also improved in Airflow 3. So you can see clearly who is writing to the assets and how the asset is triggering the downstream DAG to be running. Well, in this talk, I covered a lot of options: time-based, dataset, and asset-based, and even like external trigger. So the question is like, which one should I pick for my DAG? And I'm gonna go through a couple of examples. So I would say that you should choose a time-based scheduling when your job is really periodic and doesn't depend on external data. So for example, we have a job that's like it runs like quarterly to compile the tax statement. So in that case, it doesn't really make sense to use the other two, and time-based scheduling makes the most sense. And also, we have another DAG that's like generating a weekly support. In those two cases, latency is not really our priority, But predictability is predictability and stability are our priorities here. You just need it to run at a certain time, and that's it. So it's great when simplicity and predictability matters more than latency, and the cron job is probably your best choice here. And you should probably use data or asset-driven scheduling when your workflows depend on upstream data, especially is data produced in an upstream DAG in the Airflow ecosystem. So instead of running every hour to check on new files, just let the event itself trigger the run. And this can keep your pipelines very thin. They will only need to run when they are needed. And this is also great for breaking your DAGs into smaller pieces, smaller DAG, each owned by like different team. And it's also make DAGs easy to maintain. And in the end, if your DAG is listening to external resources such as S3 or SQS messages, you could use the asset watcher to listen to those events that are happening outside. So this is perfect for near real-time or streaming adjacent use cases where you want to kickstart small batches quickly. So to conclude, Airflow isn't just a cron scheduler anymore. You have a lot of options, and you should really think about like which is the best scheduling strategy for your DAG use case. And in migrating DAG between different scheduling, I learned a lot of lessons about how to design DAGs for better maintenance and how to keep DAGs clean and reliable. The first is that we should always keep our DAGs focused and modular. I'm not sure what's the worst DAG you guys have seen, but I've seen DAGs with like hundreds of tasks in one single DAG, and that is definitely like a nightmare moment for me. Because in my opinion, each DAG should only contain one logical workflow or just one data product. You shouldn't really try to squeeze everything into one single DAG. And when you break a big pipeline into smaller ones, it makes migration easier, and it's much easier to see the ownership. And also, whenever failure happens, it really constrains the failure only to that one single component instead of just affecting the whole chain. And it also opens up reusability because other pipelines may be reusing the data set your DAG is producing. The next is try to avoid duplication and reinventing the wheel. So oftentimes I see people creating customized operator when what they are trying to do is already covered by operators that are available in open source. So always try to see if any other people have already done what you have done before and reuse components if possible, instead of trying to create new logic or even like nested logic on top of each other. And the last one is to test and simulate your workflows. This is especially important in the world of event-driven workflows because events are not perfect. Imagine the case that sometimes event can come like twice when it should come only once. So in those cases, you want to make sure that your DAG is kind of ready for those scenarios and is able to handle those like duplicate event notification. Well, the most important lesson I guess I learned from testing different strategy is that DAG should be idempotent. You can see how I think it's really important as I put it in its individual slide. So idempotency means that running the same job twice, it should have the same effect as running it once. So there should be no double counting, no overriding something wrong, and no weird side effects. This is very important as we are moving into the event-driven scheduling because as I mentioned earlier, let's say we have a file uploaded to S3 bucket. It could be that S3 like incorrectly sent us 2 file arrived notification by mistake. However, your test should be able to handle those cases and there shouldn't be data corruption. It's also very important for retries, backfills, and migrations. So one tip to do that is to always do like overriding and upsorting instead of just append blindly and insert blindly. Well, so the idea is to make your pipeline safe to run anytime and any number of times. So that concludes my talk today. I hope this gives you a clearer picture of the Airflow scheduling evolution and how you can leverage it for your own projects. And if you are curious to chat more on Airflow data platform or how we use it at Notion, feel free to connect me on LinkedIn or talk to me afterwards. Happy to keep the conversation going. Thank you.